Hey everybody, I wanted to walk through the binomial theorem with you and remind you, first of all, when you ask to do that on a quiz or a test, the things I'm going to give you are going to be manageable enough to do with Pascal's triangle, which we went over in class. But for the purposes of the ALEKS assignment, you're going to need to be able to do binomial expansions that have really big powers on them, and that's where Pascal's triangle kind of like goes by the wayside. So I'm going to show you how to do those on your calculator. We're going to come back to those later in the year and talk about why they work the way they do. So just a reminder, when I'm doing the binomial theorem, you have those three columns. The first column is the numbers from Pascal's triangle that matches up with whatever the power is that we're expanding. So first row is to the 0, second, third, fourth, zero, first, second, third, fourth. And you can always tell it's the row that has this second number that matches the power. So I'm going to take those numbers and put those in to my Pascal's triangle column. And then the x is the first term. You start by raising it to the I'm too lazy to actually make this look pretty, to the power that you're raising everything to, and then you bring those down by 1 every time. And then you do the same thing with the second term, making sure you're actually raising the whole thing, but you start with the lower power, 0, not the lower power, but you start with 0 and work your way up. I should have already typed these in, so you don't have to watch me be boring and type these in as I go along, but that's fine. We'll be just fine. Raise to the third, and then to the fourth. Okay, now let's say you didn't have these Pascal's triangles numbers and you had to do these with a calculator. Now there is a way of calculating these things on the calculator. If you notice, if I were to FOIL this thing out, the top row I would have 4 x's and 0 y's, and the second one I would have 3 x's and 1 y, and the third one I'd have 2 x's and 2 y's. I'm always going to have 4 variables there, right? The difference is the number of those things that goes to the x's and the number of those things that go to the 3 y's. Okay. So if I were using my calculator on this, there is a way that your calculator can actually calculate how, like, if you have a group of things, like here we would have 4 variables that we're trying to pick stuff out of, where you can calculate how many ways there are of picking a certain number of variables out of a group. So that is called a combination. It's a thing where the order doesn't matter. We just care about how many of each kind we've got. So in order to do a combination, here's how this works. For this first coefficient, I would have type in 4, because I have 4 things overall, because I'm raising everything to the 4th power. And then the command to do a combination is on your calculator under the math menu. The math button's right here. And then it's under this probability menu, because combinations and their friends permutations are essentially ways of calculating the numbers of ways things can be done, which is useful in probability. So this command right here, this NCR, it's basically so the combination of n things taken r at a time. So n, which is the number we already typed in, is the number of things we have overall. It's the power on the binomial. Then we do this command, and then we want to know how many things we want to choose. So for this first one, we're going to choose all x's. So we're going to choose 4 things there. And that gives me 1. That means basically if I were to have a group of 4 things and reach in and take all 4 of them, there's only one way that can happen. So I would put a 1 there. For the next row, I'm taking 4 things. But this time, no second, just needing the math menu, get off that. Instead of taking all 4 things for the x's, I'm only taking 3 of them. So I want 4 things overall, but I'm taking 3 x's out of it. So I'm going to do 4 things taken 3 at a time. And that's 4. By the way, do you notice? 1, 4. So when we go to do the next one, which is 4 things taken 2 at a time, I bet it'll be 6. Let's see. 4 things taken 2 at a time. Hey, it's 6. So if I went ahead and did the other ones, I would get the same numbers in Pascal's triangle through this operation. So then I would do the same sort of thing I did before, where like this middle term, where it's x squared y squared, would be 6 times 1 x squared times 9y squared, because both the 3 and the y are being squared. So the coefficient of that would be 54. So essentially, when I have a problem, and let me give you a new one here, something like, let's make it pretty this time. Insert equation. Let's say that's x minus 2y to the 19th. And then I wanted to know what's the coefficient of the x to the 16th y to the third term, maybe? Now, the way you do this is like this. The chart would still have, let me put a little chart in here. I'm only going to look at the row of the thing that I care about. So I'm just going to do a row with 3 things in it. This is going to be the Pascal's triangle thing. This is going to be the x to the 6th blah, and it's going to be the y to the 3rd. So if you look at what's here, this is the first term, right? And it's raised to that power. It's raised to the 16th. So I'm going to put in x to the 16th. And then the second thing has a y to the 3rd in it. But remember the y, you have to do the entire term, not just the variable. So this would be a negative 2y raised to the 3rd. It's that typical, they add up, to 19 things overall. And then for the number that would come from Pascal's triangle, instead of getting that from Pascal's triangle, because we'd have to have 20 rows of this thing, we're going to use the command on the calculator. And what we want is 19 things taken 16 at a time, because we're using 16 on the x. So here we go. I'm going to type in 19, do the command, combinations, taken 16 at a time. This number is the number that would arise in Pascal's triangle in that spot without having to write out all those things. So the 969 is what's going to go here. So then when I'm looking at the coefficient, it would have the 969 times the x to the 16th times the negative 2y cubed. So that would be both the negative 2 being cubed and the y being cubed. So that would be negative 8y cubed. So when you went to combine all these things, the 969 would get multiplied by the negative 8. And all I have to do is just do answer. Oop, nope. Just do answer times negative 8, negative 7752, and that would be the coefficient of the x to the 16th y to the 3rd term. Like I said, on the test, it'll be manageable enough where you'll be able to use Pascal's triangle, but for the ALEKS stuff, you're going to need to want to use this method of finding that number you would get from Pascal's triangle. Just don't forget that it contains this number, but it also contains whatever number you're actually raising in the part for the binomial theorem.